second in our DevDays online series. Yesterday, on Tuesday, Jim Quancy gave a presentation on an overview of the Forge APIs, the latest state, and the roadmap looking forward. That's going to be posted very soon, and attendees for that will be notified of the location. Today we're talking about AutoCAD APIs and the design automation APIs. My name is Stephen Preston. I'm sitting here in the Autodesk San Rafael office in California, and I'll be talking about the AutoCAD APIs. And then we have my colleague Philippe Liefsma, who's based in Neuchâtel, who will be talking about design automation. Do you want to say hello, Philippe?
Yeah, hi everybody, welcome to this webcast.
Okay, so let's get going. So I'm going to talk a little bit about the product, which really means kind of a release cycle and the APIs. Oops, going too fast. So the code name for this year's release is called AutoCAD Omega, but all our customers will know it as AutoCAD 2018. And just to answer the obvious question, which a few people have actually asked, because we call it Omega, it doesn't mean it's the last ever AutoCAD release. The fact that Omega is the last letter in the Greek alphabet is not relevant. It's just someone chose that to represent O, because the last one was N. Before moving on to the APIs, I wanted to talk a little bit about that release cycle. So this is a slide that we showed in 2015 DevDays, where we talked about our intention to move away from these large annual releases. And the plan we told you about was that the idea was that for 2017 we'd release the major release and we'd have some point releases. And this has been enabled by our move to a subscription model. Basically, the accounting rules change when you move from a permanent license model to a subscription model, in that you're actually, when you have permanent license model, you're not actually allowed to ship valuable feature updates mid-year. But once you move on to subscription, you are allowed to do that, and that's a big reason why we wanted to make the move. So the plan was that we released AutoCAD 2017, and then introduce additional feature updates as well as the usual bug fix patches through the year. And then for 2018, again, this is the slide we presented in the previous DevDays. So our plan was for the 2018 release that we would do the same thing. We'd release that a year later. But then at some point in the future, we said we're going to move away from this annual release. And the idea will be then that maybe once every 3, 4, 5 years, whatever the appropriate interval needs to be, we would be rolling up everything into a major release, but the interim would just see just additional point releases. And the important thing about these point releases is they're cumulative. So I can't skip release 1 and release 2 and just install the functionality in release 3 in the update 3. The update 3 will automatically install all of the functionality in 1 and 2 as well. So that's what we presented as our intention. But this is this idea of getting away from the annual release cycle is a long-term goal. There's actually a lot of work needs to be done. There's a huge amount of dependencies on AutoCAD internally. Many of all the AutoCAD verticals, even the non-AutoCAD based applications have dependencies on the AutoCAD code base, because they typically include the real DWG functionality to export as DWG or to import DWGs. So the situation we're in now is this. So the green dots show you basically what is definite. The red dots show what we expect, but of course, being a future-looking thing, that it's possible things may change slightly. So what we definitely have done is we've given you a point update on AutoCAD 2017, and I think it's fair to say at this point in the development cycle that we're definitely going to be releasing AutoCAD 2018 in the usual time period in late March, and we plan again that we will have a point update to AutoCAD 2018. What is not clear yet is if we will have additional point updates for 2017. And at the moment, the clever money is on the next year. This is, let's say this is definite, but we will have a major release next year at the same time as well. So it's taken us a little bit longer than we'd hoped to move to the non-annual release cycle. That is still the plan. But I think for this, definitely for this year and probably for next year as well, we'll still have the annual release in play. And then the question mark is how many of these point feature updates are we going to be released? That's not clear yet. So that's the situation we're in today. Still moving towards that what we described in 2015 as the end of the big R. It's just taken us a little bit of time to get there. Talking about the technology cycle, this is a slide that actually normally Jim Quancy does these presentations at DevDays. So it's a big boots to fill for me to be actually presenting this slide because it's actually quite complicated. But basically, this where it says AutoCAD Omega here, that's a 2018 release. AutoCAD Pi is the 2019 release. And what you're seeing here is this is the breakpoint here between the releases. So you can see that we've had the same DWG format now for many years, since AutoCAD 2013. For this release, we are breaking the DWG format. Similarly for binary compatibility, that's kind of an interesting one. We are breaking it. It's a relatively small one, and there is a change in compiler. So you will have to recompile your applications if you're a C++ developer. The compiler situation is slightly complicated because we're on the same compiler, but it's a different update version. So I'll talk a little bit more about that in a moment. In terms of AutoCAD feature enhancements, now I'm not going to talk in depth about AutoCAD features. In fact, I'm not going to talk at all about AutoCAD features today. This is just a highlight of what we gave you in the point release for AutoCAD 2017 Update 1, and this is the functionality that we'll be releasing in AutoCAD 2018, AutoCAD Omega. But that has already been covered. We already ran a webcast, Meet the Expert, AutoCAD Omega with Heidi Hewitt. We have that recording posted on the AGN extranet now. I've included a very easy to remember link here for you to access that. Obviously, you'll have the available recording of this if you're not fast enough to write that down right now. But basically, go to the AGN extranet and you'll find that. And because we already have that covered in great detail, I'm not going to spend time on features today. I'm purely going to focus on the APIs. Which brings us to the APIs. So just as a reminder, we have kind of various ways of interacting with DWGs. In terms of editing, that means a user actually doing stuff on screen with his mouse. We obviously have the Autodesk desktop product, and that of course exists for Windows and Mac. But we also have other options available. So if your application wants to export DWG, we have the real DWG software product. If you want to have a branded version of AutoCAD, but which holds some of the functionality of AutoCAD, you obviously have AutoCAD OEM. I kind of view those as part of the desktop product range. However, if you want to provide do some kind of automated non-user interaction kind of operations on DWGs, either automated creation of DWGs or automated editing or automated data extraction, we have this design automation API, which is basically a headless version of AutoCAD sitting on an Autodesk server, which you can access, and you can upload scripts and .NET applications and CRX applications and run those against drawings, and that's what Philippe will be talking about later. And of course, for viewing a markup, you can very simply bring a DWG into our A360 team interface in order to share that and mark it up with your collaborators. We obviously also have our Forge APIs. One of which is the viewer. One API is the JavaScript viewer, which we use in A360, so you can actually implement your own application around displaying DWGs or any other design data, really. So in terms of migration, and actually before I go into migration details, essentially there are no significant new APIs to talk about today. You'll find in the Object-ARX help files information on on some small changes and enhancements, but there are no big feature APIs for this release. So this release is all about migration, and it is a relatively straightforward migration. It is a binary breaking release, so the major version number has changed. As I said, we're moving from Visual Studio 2015 Update 1 to Visual Studio 2015 Update 3. .NET Framework is 4.6, VC 1.4. So if you're using package content or you're writing for registry, you need to use R22.0. And the DWG and DXF format is changing as well, as I mentioned. So first thing about Visual Studio Update 3 instead of Update 1. In terms of compiler compatibility, so first I'm going to tell you what Autodesk do. So our engineering team are extremely strict about matching compiler versions with the product that they're building. So for example, for AutoCAD 2017, they make absolutely sure that any updates they make for AutoCAD 2017, for example, the feature release that I mentioned before, they make sure they have a computer with Visual Studio 2015 Update 1 installed. And then when they develop applications for AutoCAD 2018, or when they're developing on that, they make sure that they only have Visual Studio 2015 Update 3 installed. So they're very strict about matching the exact update version when they do their builds. The situation is a little bit different, or it could be a little bit different for you. If you want to adopt the strict policy that the AutoCAD product team adopt, then you need to do the same. You need to have separated development environments for AutoCAD 2017 and AutoCAD 2018. However, Microsoft do tell us that these updates are compatible with each other. So it should be fine for you to take Visual Studio 2015 Update 1 and build AutoCAD 2018 applications with it. And because we ourselves using Update 3, we will actually have installed the C++ Update 3 runtime on the machine for you, and so that will just automatically take care of it and everything should work fine. Similarly, you should be able to use Visual Studio 2015 Update 3 to build your AutoCAD 2017 applications. But if you do that, you have to bear in mind with your installer that the Update 3 runtime may not have been installed on that machine, in which case you would need to make sure that your installer deployed the Update 3 runtime if it wasn't already installed. So that adds a slight complication if you decide to use Update 3 for 2017 development. And obviously, because the AutoCAD team are very strict about their development environments, they have only tested the pure configurations, if you like, using Update 1 for 2017 and Update 3 for 2018. So, you have that information now and you can make your decision as to how you want to handle that. I think the problem most people have is it's kind of hard to stop Visual Studio applying the updates. So anyway, the other migration steps you have to take are you change the platform toolset in Visual Studio to v140, and you change all your linker settings to change from the .21, the star 2.1 versions of the libraries to the star 2.2 versions of the C++ libraries. There's some other migration steps as well. We would like you to apply these compiler security settings flags to improve the security of your ObjectRx applications, and we're also you also need to start removing dependencies on legacy Visual Studio runtimes, because AutoCAD isn't going to be able to run applications that have these dependencies, or more to the point, Microsoft is planning on deprecating support for these anyway. So for examples of that is the 100 files, which I think is from Visual Studio 2010. In terms of, so that's ObjectRx. The good news for those of you who are doing .NET and Lisp is there should be no migration required. However, you do need to test. And obviously this presentation we first gave back in November, and there was time to test with the betas. Right now you're in the release candidate, so if you've not tested already, I'd recommend you do so immediately, because it's reaching the point of no return in terms of if there's a very small issue which affects only you, it's very difficult for our engineering team at this point in the release cycle to remaster the builds that they're creating. So we need to know from you ASAP if you experience any problems. And our experience so far is we haven't had, I'm not aware of any significant problems have been reported by the people who have tested, so hopefully you're okay. Just wanted to take an opportunity as well to remind you about trusted paths. So this is really something that we did in AutoCAD 2017. We now decide how to trust applications depending on where they're installed and whether they're signed or not. So basically anything in program files we trust. So you don't necessarily have to sign anything that you deploy to the program files directory, because the way AutoCAD views that is if you've given somebody access to install malicious code in your program files directory, you have more serious problems than we can fix for you anyway. But the big issue is people deploying applications which potentially only need standard user privileges to deploy, which may contain malicious code, and because of that, we don't trust any applications which are loaded from outside a program file. So particularly the program data and app data locations, we don't trust those unless they're digitally signed. So you can see a picture of a dialog here. The user will receive, unless a user turns off all of their security, they will see a warning. So if you're deploying your application to those locations, which if you're writing applications for the App Store, you probably are deploying them to those locations, you really need to digitally sign the application so that your user doesn't receive these worrying warnings when they load your app. And the way you do that, of course, is simply to digitally sign it. Digital signatures are getting pretty cheap these days. You only need one digital certificate to sign all of your applications. They're as cheap now as I think it's about $170 for the year, and that just tells the customer that they can trust you, is the idea. Obviously, someone could buy a digital certificate and create malicious code, but once that is detected, that certificate would be invalidated by the vendor, and so anybody else would then receive a warning. So it's a certain level of security for your customers and reassurance to them. And there's Windows tools for signing those if you have .NET or C++ APIs. You can also sign Lisp APIs. So in the AutoCAD installation directory, we have this AC sign apply.exe, which you can actually use to sign Lisp files as well. And if you don't have a signed Lisp file, as I said, AutoCAD will warn the user that there's an unsigned Lisp file being loaded. So that is the end of the API section. As I said, it's all about migration this year, and the migration should be relatively trivial. So with that, before we move on to Philippe talking about AutoCAD I/O, let me just stop and give people a chance to type questions in the Q&A console. So if you type your questions, Philippe and I will try and answer them by speaking. Oops, I've just lost my screen. Okay, so give people a couple of seconds to start typing.
Yeah, so Stephen, we had a question about signing VBA. So I was answering that as far as I know, there is no way to sign a VBA. The suggested workaround would be to use a .NET DLL, and you still can use the COM API from .NET DLL.
Yeah, but obviously people want VBA because it's kind of easier to load and deploy. But yeah, we don't have plans at the moment to add the signing capability to VBA files. Okay, well I seem to have lost my mouse, so I can't read the next question coming in, Philippe. So can you read it out? Oh, there's my mouse.
Can Design Automation API do all the things that can be done through Grid DWG API? I'm pretty sure it can, yeah, because the design Automation API is really AutoCAD running in the cloud. So yeah, I would say yes.
Yeah, we're kind of stealing your thunder, Philippe, by talking about design automation before you get to your presentation. I mean, I would agree, Philippe, and it adds more as well. So one of the big, you know, over the years, I've received a lot of people who are really interested in using real DWG, and then they say, "Oh yeah, and I want to plot," and then they get very, very disappointed when they find that real DWG doesn't include the plotting API, when of course from Design Automation API you can plot, which is a really big thing. Okay. So do you want to start setting up now, Philippe? I'm going to make you the presenter.
Yeah.
And I'm going to turn off my webcam so I can relax without anybody seeing me. And you've got your webcam on. And we'll just see if any more questions come in. We'll stop again for questions at the end of the presentation. So if you think of any questions around the AutoCAD APIs, you can always ask them at the end. So are you ready, Philippe?
Yeah.
Okay, so off you go.
Let me know if you can see my screen and my webcam and everything is all right.
I can see you. I can see your screen. Yeah.
Right. So yeah, I'm going to talk about design automation. So this presentation is not an introduction to design automation. So if you don't have any experience with this API, then you may, I think, check a presentation from last year. So it's actually just an update based on the thing we already had in the API. So the first thing is that we renamed this API. It was called AutoCAD IO, and now we renamed that Design Automation. So that's because the scope of this technology is going to be extended not only to AutoCAD, but in the near future to some other desktop products like Inventor and Revit. So the name is wider now. So there is only one thing that is new.
Yeah, actually, Philippe, sorry, I'm going to interrupt you very quickly, and I'm going to ask. Let's just give a very quick overview of what design automation is. And I can do that if you like, just in case there are people who don't know. So, just to be clear, design automation API is it's a web service API, so it's a headless version of AutoCAD which runs on an Autodesk server. Is not a self-hosted solution, and basically you can either create drawings or you can modify drawings, and you can put the output wherever you like. So you basically can run scripts and .NET applications and Lisp applications and CRX applications on a DWG, and that might be something like, for example, updating a title block or exporting plotting a PDF file. And it's all online, so it allows you either from your desktop application to use this web service to create or modify a DWG, or from something like a mobile application or a web application. And it's part of the Autodesk Forge APIs, which you can access from developer.autodesk.com. Okay, sorry, Philippe. Carry on.
Yeah. Yeah. So yeah, I wanted to mention that you have three core concepts in design automation. So the first one is the activity. So it's like the definition of a job. So for example, the plot to PDF. So it's basically defining the script that invoke the command plot to PDF, taking the input file and also the name of the PDF file you want to output. The second core concept is the work item. So basically the work item is a concrete job. So that's invoking the activity plot to PDF and passing the input file and the output name. And the third core concept is the app package. So the app package lets you upload your custom autoloader package, so where you can put C++, .NET, or Lisp file, and you can upload that as a zip to the server, and you will then be able to run those packages inside your custom activities. So this gives some really powerful capabilities to the web service, because you can just grab some existing code that you have in .NET or in C++, and you can create your custom app packages and run that directly in the cloud. And another interesting thing that you can do with the app package is to pack a complete real DWG application and run that instead of the normal AutoCAD engine. So it means that basically you can run your own real DWG application in the cloud through the service. So let me show you, if you are just starting with design automation, you can check our GitHub repository. So github.com Autodesk-Forge, and this is the latest repository that we created. We clean up a bit our samples comparing to last year. So yeah, you should be able to find up-to-date samples in that repository. So you can type design.automation, and from there you can find the basic samples in .NET. We also have a sample in Java if you are interested. So this is a very basic thing. You can step through this code if you get started. It's just to illustrate how to run a very basic activity. We also have the .NET, so the input and output sample. This shows you how you can use various kind of cloud storage in order to pass the files and to output the results of the service. And also this one, the custom activity sample, that shows you how you can programmatically create an app package and upload that to the service and run your custom code against the design automation. And yeah, then you can see we have some of the sample in Java, Python, and so on. So concerning the updates for this year, there is only one major feature which has been added to the service, and that's the capability to export your custom X data, which are attached to your AutoCAD entities, in order to access them through the viewer. So let me show you the sample. So you can access the sample from this URL. So that's the Design Automation Custom Data Viewer. And you can see here it's pretty detailed, so you can follow the indication here to set it up. And so there is a bit of steps. So let me show you here that I downloaded locally the project. So the project is using an AWS Lambda Server. So you may use that, or you may as well run the project on a completely different server. So you can see here the server is pretty basic. It's just a very simple Node.js server. And also inside the setup directory, you have the scripts which are needed in order to deploy this sample on the Lambda server. So you can just replace, if you have an Amazon account, you can replace your keys here, and then you should be able to easily deploy the sample. And so concerning the code specific to design automation, we can first take a look at this RX app. So it contains the code which is used in the custom app package, in the custom activities. So let me show you quickly. So it defines two commands. The first command is the test command. So this command will simply extract all the X data which are attached to the entities inside your AutoCAD document, and it will export those X data. It will store those X data to a file on the server. So you can see it's pretty standard AutoCAD.NET API code. So iterating through all the entities inside our model space, and then it will check the X data which are attached to our entities. It will store the X data inside our custom structure, and then it will export. It will stream the result into a JSON file on the disk. Then we have a second command which simply creates a custom polyline. So you can see this is using this wrapper. So it will create a custom polyline and just attach some default X data to this entity. So that's our two custom commands, and the rest of the code here inside the client application. So this is those are the API calls to the Design Automation API, and I'm going to show you just here the contents of the scripts which are used to create our custom activities. So we have three activities. The first one is the publish 2D. So this is for 2D DWGs. The second one is the publish 3D. So those are for 3D DWGs. And we also have the publish activity custom, which is running our test polyline. So we can see here the scripts for 2D and 3D activities. So they are pretty similar. So the first command is that test command that will extract the X data from the drawing, and here we specify the output file name. So it means that it will create this xdata.json file that contains all our X data on the server, and then those are specific commands which are already defined in AutoCAD. So those are commands which are specific to design automation, and this indicates AutoCAD that it will extract the properties of our drawing into a file that is called index.json. So it will prepare this file for property extraction, then it will index the extractor, and finally it call the command publish to F2D. So it means that it will create a package for 2D DWGs, and finally here it will so this command will actually produce the files which are needed by the viewer, and this command will just create a package that can be loaded inside the viewer. And the 3D command is exactly the same than the 2D, except that here we are invoking the publish to SVF instead of the publish to F2D, and the result as well here needs to be SVF. And also we have the last command, which is the script custom. So in that case, it's the same than previously, but this command will generate the drawing that contains our custom polyline, and then it will extract the X data and create the 2D package for the viewer. So that's pretty much it. The rest of the code is pretty standard API calls to the design automation in order to run the activities, upload the package, and so on. So let me now show you the client side. which is using this code and invoking the API. So we have the viewer.html that contains the viewer code. So we can see here, so first we're referencing the versions of the viewer. And what is doing this code is that it will check the URLs which are provided in query parameters. So we access the viewer document, we access the location of the file that we generated that contains our Xdata, and also the viewer type, if it's a 2D or a 3D drawing that we are loading. So basically this code will send an HTTP request to access this Xdata, the JSON file on the server, and then you can see it will store the information about each Xdata. It's actually a mapping between the AutoCAD entity, or the AutoCAD handle of the entity, and the values of those Xdata. So it makes the information available in this Xdata info, and then you can see it will load the package that we created. So in that case, it's actually similar to a local loading. So even if the data is on the cloud, you are not loading the data directly from the Autodesk cloud. So it means that the package which is generated by the design automation is then available on your server, or you can transfer this package wherever you want and load the models in the viewer directly from this resource. So we are loading that in the viewer, instantiating the viewer, and loading this custom extension which is doing the display of the Xdata. So if I show you quickly the code for this extension, you can see it's creating a simple panel, and it's listening to the selection change. You can see there the selection change event. So every time we select an entity on the model in the viewer, then it will display the Xdata. And this is the code for displaying the Xdata. So we take as input the ID of the entity inside the viewer. We will iterate through the properties of this entity in order to find the element ID, and so the property that contains this element ID. So the value of this element ID is actually the handle of the entity inside AutoCAD. So we will use that handle in order to find the mapping in our Xdata JSON file and display the various Xdata inside this panel. So let me show you how it looks like concretely on the sample. So this is the live version of the project. And yeah, I don't have a good 3D or 2D drawings, but I can show you this one. So this will invoke the custom command, so creating a drawing that contains our polyline, adding on the fly the custom Xdata, and then it should be available for viewing in a few seconds. All right, so now I'll click on the viewer, and then so you can see here inside the URL are the various parameters. So those are the locations of the viewable packages, and also the location of the Xdata files. And yeah, it's a pretty simple drawing that just contains one entity. But so if I click here, then you can see that the our panel is displaying the Xdata which are attached to this entity. So yeah, it's not a very advanced sample.
Yeah, Philippe, I think I'm not sure your panel displayed there. Have you got the viewer displayed?
Yeah, can you see it? over
Your
there.
screen seems to have
Yeah.
unshared, I think.
Okay. Is it all right now?
There it is. Yeah, yeah.
Yeah. Okay. Sorry about that. So yeah, you can see that's entity, and so whenever I select this entity, you can see the Xdata, which are retrieved from the mapping. So it's not a very advanced or concrete example, but yeah, it makes the point. So it keeps the thing rather straightforward and easy to understand. Yeah, so yeah, that's it. I hope this is useful.
So I think I'm not sure, Philippe. I'm not sure you explained at the beginning why this was really interesting. So obviously, what Philippe is showing here is the Forge viewer, which I mentioned before, which is capable of displaying 2D and 3D drawings. And that viewer, it extracts the standard object data about different objects in the file. Like if you have a line, it'll tell you its layer and its line type and things like that. But there was no way of displaying your custom application data. And so basically what has been added to AutoCAD IO, as was now Design Automation API, is the ability. So up until now, to translate a DWG, you had to use the Forge Model Derivative API, and it didn't handle any of this custom data. So what you now have is the option of using Design Automation API to extract your own custom data from a DWG. And actually, if you don't mind, Philippe, I'm just going to steal the screen for a second, just to show another example. So I have an example here, which I just ran. I have a slightly different drawing than Philippe. So this is a 3D drawing, obviously, and you have a standard viewer, and I can zoom and pan and rotate and all of that kind of stuff. And there's X data associated with certain objects in the same way that it was with Philippe's custom entity. So if I click on this object here, it doesn't display anything because there's no X data. Whereas if I click an object here, I can display all of those DXF codes and the values associated with them. Now, obviously in a real life, you wouldn't display, oh, DXF code 1040 is 45. You would know that that particular DXF code 1040 actually meant something like, you know, the inner diameter of a pipe, or, you know, the pressure rating, or whatever it was. And so you'd have, you know, real human readable values being displayed in the viewer. So the point is now is that if the model derivative API doesn't extract the data that you needed, you can use a Design Automation API to extract this additional data and make it available to the viewer to allow you to create a web application that can display your custom entities, your custom data inside the inside your web application and using the viewer. So did you have more to present, Philippe?
That's it. Yeah.
Okay. So I think that's it then for the Design Automation API. You know, the other thing to just bear in mind is all of this is available from the developer portal. You saw the GitHub samples. If you go to developer portal here, you have the documentation for the Design Automation API. You've got overview of the API. You've got a step-by-step getting started tutorial. You have the API reference, a reminder about the GitHub. And I actually prefer our GitHub IO page, Philippe. I know you'd like to go right to the source. But if you go to autodesk-forge.github.io and filter for the Design Automation APIs, you'll see all the APIs listed here. And if you're interested in a particular language, you can choose a particular language to filter by. So, for example, we've got quite a few C# examples. And then if you click on one of these, it takes you. This is the sample Philippe was demonstrating today. It takes you straight to the actual GitHub repository where you can clone or download or fork the repository and then use it yourself. Okay, so I think then with that, it's time to, I'm actually going to stop the recording now, and then we will move on to taking questions. So I'm stopping the recording.